Hi everybody, Miss Martello here. I just wanted to talk about a couple applications of the Pythagorean Theorem. The first problem that I have is one where you're given a picture that kind of looks like a big triangle with two triangles inside of it. It says given that triangle HAM, which is the one more on the left side, HAM, and HAT, so the one more on the right side, are right triangles, find the length of MT. So MT would be this whole like top side here, all the way from M to the T. And it says that we're given that those two triangles, HAM and HAT, are right triangles. So the first thing that I'm going to do is draw the little box in there so I know that they both are supposed to be right triangles. And I think it's helpful to look at one triangle at a time. So say that I start with HAM. And it's kind of small, but I did the yellow is supposed to be the legs. So remember the legs are the sides that make like the L shape. It's kind of rotated around here, but they would be forming the right angle or the L shape, and then the green one is the hypotenuse. So right now we know that one of our legs is 6, and then the hypotenuse is 10, and then we don't know the other side. But you figure this side MA, I could call it X, and then I would be able to write Pythagorean theorem just like we've been doing. So, and if it's hard to see on the big picture, I did just draw it down here separately. So we got 6 is one leg, X is the other leg, and then 10 is the hypotenuse. So when I go to set this up, then if I know the Pythagorean theorem is leg squared plus leg squared equals the hypotenuse squared, then I should have 6 squared plus x squared equals 10 squared. Because again, 6 and x were the legs, and then 10 was the hypotenuse. So then I can go through and solve. So then you figure I have addition and I have exponents on the left-hand side. So order of operations tells me to do parentheses and exponents first. So I need to do the exponents next. So 6 squared is 36 and 10 squared is going to be 100. Remember, 6 squared is like 6 times 6. 10 squared is like 10 times 10. From there, though, I'm not able to combine 36 and x squared. But I do eventually want to get the x squared by itself. So right now it's like a positive 36. So then I have to subtract 36 from both sides. You figure 36 minus 36 is 0. That would like cancel out. So I'm really only left with x squared on that side. And then 100 minus 36 is 64. So right now I have x squared is equal to 64. So like what number squared is 64? If you have a hard time thinking of a number squared that's 64, remember that the opposite of squaring is to take the square root of both sides. So I can take the square root of both sides. Remember the square root and the square cancel. I'd just be left with x. And then when I do the square root of 64, I should get 8. Remember, if you're punching that in your calculator, most calculators, to get the square root symbol to come up, you have to hit the second button and then the x squared key. So then you figure, so we just came out with x equals 8. Unfortunately, that is not our final answer, but it does tell me that on my picture from M to A, that part is 8. And you might notice that this triangle, if you figure if I have 6 and 10 there, I also have the leg 6 and hypotenuse 10 on this side. So that's actually like a congruent triangle. So if this is 8, then this should be 8 too. So then if both of those are 8, to find the length of MT, I just have to add them together. So 8 plus 8 is 16, so then the length of MT must be 16 units long. And I want to do one more example of like an application problem with Pythagorean theorem today. So the next one that I have, it says given the right triangles below, find the value of x and y. And so since it says given the right triangles below, you figure this must be a right triangle, and then the whole big thing must be a right triangle also. And they asked me to find the value of x and y. Normally when they do that, I do like to find the value of x first. So I would kind of look at the fact that you have this like smaller triangle in there. And hopefully when you kind of look at it, and I did just do highlighting with the legs and hypotenuse, hopefully you can see that the legs are going to be the 7 and the 24, and then the x must be the hypotenuse. So you figure again, I can use my Pythagorean theorem to find the length of x. So if 7 and 24 are the legs, then I'd have to do 7 squared plus 24 squared, and that would be equal to x squared. And kind of like we said with the last one, if I have exponents in addition, I am supposed to do the exponents next. So 7 squared, that's like 7 times 7, that would give me 49. 24 squared is like 24 times 24, that would give me 576. So just from there, I'd have 49 plus 576 would be x squared. I am able to combine 49 and 576. That gives me 625. So then I'll have 625 equal to x squared. And to get the x by itself, I would have to take the square root of both sides. So it's asking me like what number squared is 625. And it should come out to be 25. So then I know that the value of x is 25. And then I just wanted to note for the next part, then I still have to find y. But what's cool though is once I figure out that x is 25, then I know this entire thing here, when I add together the 4 and the 25, that whole thing then is going to be 29. So on the big triangle, the hypotenuse must be 29. And then I can do the same thing on this leg that's on the bottom. So if I know that I have 7 and 13, the whole thing must be 20. So those two sides, they're going to help me find the y value. So you figure if I look at that whole triangle as like a whole thing then, what I have in yellow would be the legs of the entire triangle. So that would be 20 is one leg from 13 and 7, and then the other leg is going to be y. But now that I know what the x value is, 4 and 25 gives me that this hypotenuse, the whole hypotenuse is going to be 29. So then I know on my figure my legs are 20 and y, and the hypotenuse is 29. So then when I go to use Pythagorean Theorem, I'm going to do 20 squared plus y squared is equal to 29 squared. So again, from my legs, which was 20 and y, and then the hypotenuse was 29. So then, again, I'm doing the exponents next. So 20 squared is 400. 29 squared is going to be 841. Because I can't combine 40 and y squared, but I want to get the y squared isolated, I'm going to have to subtract 400 on each side of the equation. 400 minus 400 is just 0, so then I just bring down my y squared. I have y squared is equal to 441. But I need to get the y by itself, or I could think too, this is asking me like what number squared is 441. And the opposite of squaring is to do the square root. When I do the square root and the square cancel out, so on the left-hand side, I'm just left with y, and then when I do the square root of 441, I should just be left with 21. So then I'm given x equals 25, and I have y equals 21. Hopefully this was helpful. Thanks for watching.